infrastructure. My name is Demir Bursnik. I'm a Senior Platform Advisor in Microsoft Canada. My contact info is on the slide. The slides, as you know, are also available, so feel free to contact me after the event if you have any questions. Basically, what I want to do is kind of bridge that gap that I've had in customer accounts on a number of occasions where the SharePoint admins aren't quite sure how to virtualize, and the IT admins aren't quite sure how to virtualize SharePoint. You guys get that? It's kind of, it falls between the cracks a little bit in terms of both sides not being quite sure. And in some organizations, there's a lot of pressure in terms of the virtualize. There's actually a lot of really good reasons to do it. So the agenda really is kind of starting to talk about what are some of the things we're seeing in terms of why customers are looking at virtualization of SharePoint, but also other workloads that we have. And then I'm going to spend a little bit of time talking about which SharePoint role should be virtualized and why, and then what's the actual impact you're going to have when you do that, and what do you need to go ahead and watch out for, as well as what are some of those best practices. One of the things that I found in a number of customer accounts is when it comes to virtualization, some of the rules on how you actually do things do change a bit. A lot of the SharePoint-oriented stuff in terms of how you deploy SharePoint, how you architect your SharePoint infrastructure overall, doesn't change that much from a SharePoint perspective. It's the implementation of that when you virtualize that actually ends up changing. So we'll kind of take a look at that, and you're going to find that I have this really simple scale based on colors: red, yellow, and green. So when I get to that part, you see red means really, really important to watch out for, yellow means less impact, and green means it's pretty well okay. Then I'm going to take you into some high availability stuff. One of the things that's really important to understand when you are virtualizing any particular workload, but also SharePoint in particular, is because you're now relying upon a single piece of physical hardware, i.e. virtualization host, to be responsible for several different workloads, that particular host failing has a much greater impact in terms of what ends up happening when it does fail. So the impact it has across the business and how you actually have to deal with that. And then what are the right things that you need to do on the SharePoint side when you virtualize it to protect yourself against things like host failure, but also dealing with things such as patching, upgrades, all that kind of stuff. So spending a little bit of time on that as well. And then finally, just give you some key takeaways. So that's really what the plan is for the session itself. I'm going to do a few demos. I'm actually going to break stuff. I don't know if you guys like it, but I'm going to blow stuff up, which usually is kind of good because you get to see what the results are. I like blowing stuff up. And then we'll see how that actually works out. Sound good? All right. So in terms of why we're virtualizing, a lot of reasons. One of the biggest reasons is that you don't necessarily want to have to fork out new hardware every single time you deploy a SharePoint infrastructure. Hardware these days is much more powerful than it was before, and even though licensing, whether you're virtualizing SharePoint or whether you're implementing a physical hardware, is really the exact same, there really is an advantage to virtualizing, such as being able to get greater availability. Also, there's wonderful things like you're more green when you have fewer pieces of hardware. The cost of running data centers goes down, and so on down the line. A lot of business reasons to go ahead and do it. And one of the things we're finding is that a lot of customers are actually being pushed towards virtualization from a lot of different areas, whether using our particular product, i.e. Hyper-V, whether using a competitor product like VMware. There really is a lot of push in organizations to start to virtualize because of what they see as the increased benefits. Interesting stat that I've read a number of times is the cost of running a data center is 60% power and cooling, 30 to 40% hardware. If you can actually reduce some of that, what ends up happening, virtualization is going to help you keep those costs down a little bit. And you guys have seen the cost of power kind of rise over the years. It's going to continue to rise, I'm pretty sure. So the other thing is to consolidate and to potentially not have as many dedicated servers, but to consolidate and have a bunch of different workloads on a particular piece of physical hardware. You've probably read this stat as well, but the average server utilization at the hardware level these days for a dedicated server is about 10% CPU utilization. 90% of the time your machine is doing nothing. How do you get more bang for the buck with regards to that particular machine? Throw a bunch of different workloads on it to make sure that you can actually go ahead and do that. So it makes it easier to provision things like specialty servers. Also, when you do, in fact, virtualize, one of the things that is really easy to do is to start improving scalability very, very quickly. And I'll give you an example. In some situations, some organizations may have kind of peak workloads when their SharePoint infrastructure is going to get hammered a lot more, whether that's for internal or external purposes, and other times it's going to end up going down. And very often what those organizations do is they will potentially provision a bunch of dedicated servers for a short time and then decommission them. With virtualization, the way of doing that is actually very, very quick, and it can be done even through an automated process by having monitoring taking place with things like Operations Manager that can kicks off a job in Virtual Machine Manager that then goes out and deploys a new web front-end server for you like that. So the process takes 10 minutes as opposed to having to get the hardware and be able to go ahead and do that and build it out from scratch. On top of that, the other benefit is you can now start to unbundle some of those pieces of SharePoint instead of having them all happening in one particular physical box. So instead of having one box that is both your front end, your application server, that's also going to potentially have your database, you start to take those pieces apart and have multiple front ends, have a potentially index and a query server that are separate or not, have a server that handles things like Excel services in one particular spot that's more dedicated. So this allows you to kind of unbundle that very, very easily as opposed to having to have that coexist on a single physical box. And that potentially also leads to fewer issues in terms of what's happening on that particular machine. So, fewer surprises, less work that you need to go ahead and do, and so on. In terms of virtualization, this is probably nothing that you guys don't already know, but it is very important that when you are virtualizing any workload today, you use a hypervisor-based virtualization software. So I kind of compare what we have today, and what we had before. I wouldn't have recommended customers virtualize SharePoint on virtual server way back when. But Hyper-V, on the other hand, is actually a really good solution for virtualizing your infrastructure. It's not the only one. There are competitive ones as well. Obviously, me being from Microsoft, I prefer that you do it on Hyper-V. But VMware is also a perfectly acceptable platform to go ahead and virtualize SharePoint, because in both cases, both of those are part of what we call the Virtualization Server Partner Program that Microsoft has that will support you when you run SharePoint in a virtualized environment with any partner that has actually passed certification to the Virtualization Server Partner Program. So it's very, very important that those types of virtualization software are being used when you virtualize SharePoint or any workload on the Microsoft side. The other thing to keep in mind is some of the things you do for monitoring actually change when you virtualize. Right? So the way that you deal with things like CPU and the way you monitor CPU is in fact somewhat different. And the way the CPU gets calculated when it's virtualized versus when it actually is running on physical hardware is a little bit different too. So, physical CPU time is not something that you actually end up monitoring too much on the virtualized version of your SharePoint infrastructure, but it is something that you do on a physical implementation of it. And that's because of the way the CPU gets reported back to things like Event Viewer and our own capability to be able to go ahead and monitor that. So there's actually very, very good documentation available on tech that in terms of what you need to monitor on a hypervisor-based environment versus what you're going to be monitoring on a physical implementation of your infrastructure. So you need to understand in terms of how to properly configure CPU when you're virtualizing versus when it's physical. Same with memory, same with network, and same with disk. And I'm going to get into every single one of those in this particular session. Kind of walk you through some of the things you need to know to properly configure all of those elements and give you some of those best practices. So I'll tell you right now, there is one particular thing that has to do with memory that has caused problems for customers more than any other. And if you don't configure memory properly when you're virtualizing your SharePoint infrastructure, what actually ends up happening is you can take a 30% performance hit out of the gate just because of incorrectly configuring memory. Really, really important thing to know. Right? Not a lot of folks actually talk about it too much, but it's an important thing to know. And that's whether it's our hypervisor or anybody else's. So with regards to Windows Server 2008 R2 Hyper-V, just some of the things that we have. The host is x64, the guest could be x86 or 64. Obviously with SharePoint, your guest operating system is going to be 64-bit. SharePoint is only 64-bit today. In terms of some other limitations, again, if you're doing a physical type of implementation of SharePoint, the number of CPUs really doesn't matter. It's based upon whatever the hardware supports. But you've got 4 virtual CPUs per virtual machine on the hypervisor on Hyper-V. So that's the other thing you have to keep in mind. You don't have 12 CPUs, you've actually got 4 that you need to go ahead and deal with. That number will probably rise over time, but it's something to keep in mind. Memory-wise, at the host level, 1 terabyte per virtual machine, 64 gigs. But even then, that may not actually be true. You may have less because of some of the architectural issues at the hardware level that are hypervisor independent that you need to actually be aware of. Networking-wise, on Hyper-V, we actually have 10 gigabit Ethernet adapters that are built out of the box, and you can actually have 12 network adapters, asynthetic formulated per virtual machine, and then disk support. One of the interesting things and the questions I often get with regards to disks for Hyper-V in particular is, okay, so I want to make sure I get the best overall performance for disk. Now, what can I go ahead and do? Well, if you're using a VHD file, or if you're using disk with regards to your SharePoint virtual machines, there's a number of different options available to you. The default is actually the worst thing you can do. So within Hyper-V, the default for disk configuration is what we call basically a dynamically expanding virtual hard drive, which means it grows over time. And it grows based upon usage. From a performance standpoint, that's actually very bad. So if you're going to use a VHD file, and you probably should use a VHD file, what you want to make sure that you take advantage of is something called fixed-size virtual hard disks, or fixed-size VHDs. You create the virtual hard disk at whatever size you allocate to it, 60 gigs, 100 gigs, whatever it is, and that space gets allocated right away. And that storage should, as you're going to see later on, really be on a back end on a SAN. And that SAN can be fiber channel, it can be iSCSI, you can whatever you want it to be, but you want to make sure that that particular storage is actually on a SAN because of things like availability issues you can deal with later on. But always use fixed-size VHDs, A, because they're VHDs and they give you a lot of flexibility in terms of moving them around, but also the performance hit on using fixed-size VHDs is about 2%. On dynamically expanding one, it can be a lot greater. Using something called a pass-through disk, where the virtual machine will actually directly talk to physical storage on a SAN, is possible. It doesn't have any real performance advantage over a fixed-size VHD. What actually does end up happening is it makes it very hard to move stuff around very easily. So using a fixed-size VHD is kind of the recommended way of going it. From the overall performance perspective, there's really no difference. We've actually done testing. I think there was a session this morning that was put on about a bunch of benchmarking results with regards to virtualizing SharePoint that kind of cover that as well. Licensing-wise, whether you're running Hyper-V or whether you're running another virtualization type vendor's product, i.e. VMware, which is, how many are running VMware, by the way? Okay. How many are running Hyper-V? A few. That's actually quite good. Thank you. What I'm talking about, though, is going to, when I get later on, is going to apply to both. It doesn't really matter which one you're running. And licensing is true as well. If you buy a copy of Windows Server 2008 R2 Standard Edition, you get to run 1 VM for free from the operating system license perspective. If you have Enterprise, you get 4 VMs for free. And if you have Data Center Edition, you get an unlimited number of VMs. And you actually have to buy that copy of Windows Server, whether you're running VMware or whether you're running Hyper-V. It works the exact same way. That does not include licensing for SharePoint. So very, very important with regards to SharePoint licensing, it doesn't change. The way you license SharePoint, whether it's physical or virtual, is the exact same. So there is no difference whatsoever in SharePoint licensing, whether it's physical or virtual. What you do get is additional benefits in terms of why you'd actually want to go ahead and do that, which I'm going to get into in a little while. So in terms of Hyper-V, just some things, because I have to talk about it because I love it, I think it's great. Things you get, live migration, moving virtual machines from one particular host to another, very, very easy to do. Your users themselves would actually never notice the fact that that particular virtual machine has, in fact, been moved. It's very similar to vMotion on the VMware world, but we think ours works a little better, but it's very similar functionality in terms of both. Hot air removal of storage, so you can add additional disk storage to a guest virtual machine while it's running, provided you actually use a SCSI adapter, virtual adapter, in order to go ahead and do that. So you need to add more disks to one of your SharePoint VMs. You can do that while it's still running, and that's totally supported. With regards to live migration, one of the things that's important to note is as you're moving from one particular host to another, the ideal is that both hosts are in fact the exact same hardware, the exact same CPU, basically they're identical. That's the ideal. The reality is that may not always be possible, especially in smaller organizations. You may have a mix and match of hardware, and you may want to run a virtual machine on one host all the time, and then once in a while move it over to a different host within that clustered environment in order to make it work. We have this option available within each virtual machine called Processor Compatibility Mode that allows you to move a virtual machine from one particular physical host to another within the same CPU family. Right? So you can't, for example, go from an Intel Xeon to an AMD, but you can't go from an Intel Xeon to another version of an Intel Xeon, or potentially an i7 and so on down the line. So it's got to be the same vendor, same CPU family, but it can in fact be a different CPU. In terms of scalability, again, scalability for 64 logical processors on a physical system, and you can actually go through and have a lot of additional functionality there. Server core parking. This gets into kind of what I call the more advanced features. Windows will, and Hyper-V also, start to churn off CPUs on a server if they're not being used. So as you find that utilization, let's say overnight, of your farm starts to decrease, we can start turning off CPUs, move virtual machines onto other CPUs, and that'll save some power. And then when the utilization goes back up, we start turning on those CPUs again. So that's a feature of Windows Server that's available as well. Second level address translation. Really, really important, whether you're using ours or other virtualization environments, that you do get motherboards and CPUs that support second level address translation. And let me kind of explain what that means. Everybody know what that means? Does anybody know what that means? What the SLAT stuff does? Okay. So when you're virtualizing any particular environment, what ends up happening is we have to do a mapping between the physical RAM on the machine and the RAM that's being utilized within the virtual machines. Right? So from a virtual machine perspective, it thinks it's got a contiguous chunk of RAM. From a physical implementation perspective, it actually doesn't have a physical, contiguous chunk of RAM. It's actually got different parts of RAM that belong to the physical host. And each virtual machine is going to have different pieces of it. What second level address translation does, it means that that process of trying to map physical to virtual RAM is not done by the operating system and using a regular CPU. It's actually done at the hardware level of the physical hardware. So having second level address translation or SLAT-based processors or SLAT-based hardware is going to give you a performance improvement when you virtualize your SharePoint environment. So the newer hardware that's been out for the last 2 or 3 years is all using SLAT-based type of processors and SLAT-based type of configurations. You want to make sure that you go ahead and do that, so that you have that, so that you're going to get that performance improvement to ensure that you've got the best overall mapping of physical to virtual hardware memory happening all the time. Very similar with things like virtual machine queuing. At the network layer, that also means that the network card can actually now do direct writes to memory within the virtual machine for network access, and that's going to give you better overall network performance. So if your network cards support virtual machine queuing, you want to go ahead and take advantage of that as well, because that's going to give you that better performance. This is something that we do in Hyper-V as well. New feature in Service Pack 1, dynamic memory. Okay. How many here have heard of the VMware term overcommit? Okay. How many here have using it in production? A couple of you? Okay. Interesting part is VMware actually doesn't recommend it to be used in production. That's the part I found interesting. Dynamic memory is kind of our answer to that. It is not the same as overcommit in that we don't overcommit memory. What we do allow you to do is to manage the memory in the exact same way we manage things like CPU resources based upon on-demand. So for each virtual machine, you can configure startup RAM, max amount of RAM, and you can specify a priority for each virtual machine in terms of which one should get the RAM ahead of another. And then as virtual machines tend to run, if we find that we're getting one particular machine that needs more RAM, we're going to allocate that to the virtual machine as required. Key recommendation here is not to have the total amount of RAM allocated to all virtual machines be more than 10 or 15% of physical RAM within the physical machine to begin with. But this is actually a really great way of dynamically scheduling RAM allocation, and it is a fully supported production capability within Hyper-V. So, with regards to virtualization hardware and virtualization hypervisors, again, use x64-based hosts for best overall memory and availability. If you find an x86-based host today, let me know, because I don't think there is one anymore. They're all 64 these days. Use the latest operating system for your guest OS for SharePoint. So that means 2008 R2 should be the guest operating system used for SharePoint 2010. So use the most up-to-date operating system at the guest level that's supported for the version of SharePoint you want to go ahead and virtualize. Make sure you've got the right management tools. And I haven't actually talked about it too much here, but one of the things that's really good from our perspective is we've got a great set of tools to manage Hyper-V, so take advantage of those. Make sure that any particular virtualization hardware platform or software platform you want to use is fully supported in the Windows Server Virtualization Partner Program. If you are going to run this on VMware or Xen or whatever it is, make sure that they've passed the SVP testing. The reason for that is we'll support you if something goes wrong. If they're not certified, we won't. We're going to ask you to put it back on physical hardware or onto one of the other ones. And then understand licensing in terms of how many OSs you get for free when you do, in fact, end up buying a copy of Windows at the different levels. And this applies to whether it's VMware, Hyper-V, any one. The licensing is the exact same at the OS level as well as at the SharePoint level. So, having kind of got that background, which SharePoint role should you virtualize? We could say all of them. But then the question is, what's the impact of doing one versus the other? So let's go through that. In terms of a SharePoint farm, you guys all know this. We do actually have a number of different roles in a SharePoint farm. In a small installation, they're all on one particular server or one particular implementation, whether that's physical or virtual. But the reality is you can't actually break them up. So you got web front-end servers. Those are the ones that actually get the requests from the users and return back the results to the user in terms of the way to go ahead and see it. So they've got SharePoint Foundation, WSS is part of that there, as well as the web application service. Then you got a number of different application servers: search server, Excel services, performance point services, access services, Visio, so on down the line. Those are the ones that actually run the applications. And then finally, you've got a database in the back end, SQL Server. Okay? So if you kind of break it down, you really kind of have three different types of roles, but each one has pros and cons for being virtualized, and we'll kind of get into why. So here's a quick snapshot. Okay? The web role really should be virtualized in almost all cases. In fact, you should have multiple web roles existing, and you should be able to dynamically add web roles as needed in order to satisfy user query requests. The query role as well, in terms of for indexing and so on. Again, for large indexes, you want to use things like fixed-size VHDs, but this is the one to process the search queries. In a lot of organizations, the query role and the index role tend to be tied together because they're not separated out, but you can, in fact, separate them out. Application roles are also good examples, but depending upon what the application is doing and how it's taking advantage of CPU, disk, or memory, you may have different reasons for virtualizing or not. Index, the search server, the index server, got to think about it. And the database role is probably the biggest argument in the SharePoint world about whether or not it should be virtualized. Some people say yes. Most folks that I talk to say, no, you shouldn't. And I'll go and say, you probably should. But let me tell you why. Right? There's different reasons for it. So here's my wonderful type of legend. So you notice there's red, green, and yellow under CPU, RAM, network, and disk. So just keep that in mind. This is a legend. What this basically says is the SharePoint, the web role, is going to be having probably the most impact on a couple of key areas: RAM and network. So you want to make sure that when you are virtualizing those particular roles, you take into consideration that you give them the appropriate amount of RAM so they operate properly, and that the network bandwidth and the way you configure that network adapter in the virtual machine is going to give it the maximum potential in terms of being able to receive and send network traffic as quickly as possible, because that's what its job is to do the work and then send the results back to the user after it gets the queries. Disk-wise, the web role really doesn't do a lot of this stuff. It does do a lot of memory stuff because it ends up caching a lot of information. So you need to have sufficient memory for it to go ahead and cache. On the CPU, it can sometimes get slightly overburdened or not. It depends upon the type of activity you actually throw at it. But in most cases, it'll have adequate CPU utilization. It might get to 40, 50, 60%, but it's not going to be stuck at 80 or 90% on a regular basis. Unless, here's the big if, you haven't configured memory properly. Then it starts paging. Then disk goes up, CPU goes up, it gets all crazy. So it really depends upon how you go through and structure the memory and so on. Virtualizing your web role is a really, really good thing to do because this allows you to very quickly build out another potential web server to your farm that people can then be able to go ahead and access as things start to get busy and as they grow over time. You can't put together a template of what a web role a SharePoint server looks like with things like System Center Virtual Machine Manager and then very quickly just deploy another one. modifying the SID, for example, and that kind of stuff. But once you get that done, it's very easy to very quickly deploy a brand new web role very, very quickly. For every single guest virtual machine that is a web role, the important thing is to keep everything at the same level. Right? At some point in time, you're going to have to do an upgrade, and one of the things that's very useful with regards to upgrading web roles in a SharePoint environment is with virtualization, you can create a snapshot. Do the update, and if everything works okay, you can then merge that snapshot. But you can always go back. On a web role, it's easy to go back. On other roles, it's not always as easy to go back, but this gives you a great way to start taking advantage of virtualization functionality in order to be able to do updates in a very, very cohesive way. Kind of a cool little approach. How many here are running more than one web server? Yeah, pretty common, right? It gives you that redundancy and capability. You definitely want to have network load balancing. I recommend offloading that to a hardware device, although you can use network load balancing within Windows. But again, there's some CPU and network usage there as well that's going to account for it, but having a hardware device is actually a good way of doing it. Always, this is actually the last point, is very important. Don't put all your web server roles in one basket, i.e. on one host. Okay? Spread these things out. In fact, spread out all of your pieces of your SharePoint architecture onto multiple physical hosts. Remember what I said at the beginning? A physical host failing when you're virtualizing stuff is going to have a much bigger impact than when you're dedicating it to a single role. So you want to make sure that you spread stuff out so you minimize the potential risk of failure. In terms of the query role, again, what it does, it processes search queries because it propagates a copy index about 10 to 30% of the documents that are being indexed. If you're going to use a query role and you're going to have some large indexes, what you want to make sure is you do, in fact, use fixed size VHDs to get that best overall performance. Or, and I didn't actually mention this before, through a virtual machine, you can, in fact, attach directly to the LUN of a SAN. However, that SAN must be iSCSI based. So it is possible to have a hard drive within a guest virtual machine that is going to go ahead and access a physical LUN as long as that LUN is iSCSI based. And that's true for Hyper-V, VMware, anyone. And the reason that only iSCSI is supported, one of the things you cannot do inside a virtual machine is install hardware-based drivers, right? Because they're virtual. However, the Microsoft iSCSI initiator is built into every single copy of Windows Server. So therefore, your Windows Server-based guest virtual machine can always connect to an iSCSI-based SAN and take advantage of it as a dedicated disk device. So you can do that as well if you need to. And that's also true for things like your index server roles, so on and the line. Again, do not put your query and index servers on the same underlying physical disk. Separate those as well. And again, should you combine or split the web query role, depends upon your environment. That gets into what's the best practice from the SharePoint perspective, and it really kind of gets into the conversation of, well, based upon my environment, what should I actually do? You need to take a look at things like, what's the overall query performance, web performance requirements that you have, and how is that going to be satisfied by combining them or by splitting them? There's no clear answer on that one. It's something that you have to kind of try out and see which one works best for you. Index role, it's going to have heavy utilization across the board. A lot of CPU, because it's going to be going through and trying to calculate indexes and get all that taken care of. A lot of RAM, because it's going to be caching information. A lot of disk, because the index is stored physically. And a lot of network, because it's going to be answering queries on a regular basis and going out and potentially crawling as well. That kind of says, well, should you virtualize it? And the reality is you probably should, but just be aware of the fact that it's going to require a fair bit of CPU allocation, RAM allocation, and so on down the line. Which means that this is the one you give as many potential virtual CPUs as you can in order for it to do what it needs to do. Give it access to the fastest hard drives, which may be a iSCSI LUN connection directly or a fixed-size VHD on a very, very fast SAN. Make sure it's got the right amount of RAM available for the amount of work it needs to go ahead and do. It's one of those things where if you do, in fact, virtualize your index server, the benefit you get is not so much on the index server part itself, it's on being able to have that index server highly available within a Hyper-V clustered environment, or potentially even like a VMware environment where it can migrate between different hosts, and should a host fail, it gets very, very quickly brought back up again in that environment, as opposed to should the host where the index server is physically running fail, you have to rebuild that host. When you virtualize any one of the different roles, you don't actually have to rebuild it. If you put it together in a cluster configuration, it simply gets brought up within a minute typically on another host and it keeps on going. So your downtime when virtualizing any particular role is significantly less in a virtualized environment than in a physical environment, because you don't have to rebuild the hardware. You simply restart the virtual machine on a different host. Right? So it's very important to kind of have that infrastructure in place as well. This is where we get into some of the high availability considerations. Again, use as fixed size VHDs or physical LUNs that are nice fuzzy sand. Other roles, typically I'd say virtualize them. Trying to combine 15 things on a particular role is probably not a good idea in a very busy environment. So, think about your overall utilization and how you want to, parcel this out. The performance point services running on the same machine as Excel services and Visio services, when all three are really, really busy, is probably not a good approach. So, don't do anything that you would do differently if you were going to implement this physically when you go virtual. In fact, think about the exact same approach as you architect that SharePoint infrastructure when you're going virtual. Those rules about SharePoint don't actually change. I mean, one of the comments I like to make when I talk about this is, if you try and fight SharePoint when you're virtualizing it, you're going to lose. Still do the right SharePoint things. Just because it's virtual doesn't change the rules of SharePoint. Rules of SharePoint stay the same. The way you implement SharePoint changes, but not the actual rules for it. Now here's the big one. Database role. Couple of interesting things here. We fully support SQL Server being virtualized. We've actually done that since 2005. But SQL Server can, in fact, be very memory disk. It can be very I/O intensive. It can be very CPU intensive, depending upon what it's doing. And it can also potentially be very network intensive. So a lot of people have said, well, don't virtualize SQL Server because, A, it's already a point of consolidation. Right? Your content databases can all be in the exact same SQL Server, and each content database can, in fact, be separate, but they're all running on one SQL Server, so therefore you're consolidating all those content databases anyway. So why worry about it? Yeah, that's potentially a relatively valid argument. Disk I/O activity is very high on SQL Server. Get that. You want the absolute maximum performance. You want to throw as much as you can at SQL Server. So yeah, I absolutely get that. And if your SQL Server is in fact virtualized and it's not performing well, it's going to have a great impact across the entire SharePoint infrastructure, because everything relies upon SQL Server being properly configured, right? A lot of really good arguments. And also you get SQL aliasing, which can kind of help you out too. So first thing I'd say is look at the Microsoft Assessment and Planning Toolkit and kind of determine what it says and how it can let you know whether or not it's a good candidate. But there are some other things to do with regards to virtualization. Okay? Virtualizing SQL Server does give you the capability to potentially have multiple SQL Server instances, each dedicated to a particular part of your SharePoint infrastructure. The reason I say that is licensing for SQL Server virtually is different than SharePoint. And this is where people get a little confused, and I myself think that we should try and unify this, but the reality is it is in fact different today. So whereas SharePoint licensing in virtual environments is the exact same as SharePoint licensing in physical environments, when it goes to SQL Server, it depends upon how you license it. If you license SQL Server based upon the number of sockets in the physical host, you can install as many instances of SQL Server on that physical host as you want in a virtual environment. So you can run 5 SQL servers, and you're still good. Or you can license it per virtual machine, in which case you're limited to what's in that virtual machine. So you can't do that for SharePoint, though. You can't say, well, I'm going to license SharePoint based upon the physical sockets of that physical machine, and then be able to run as many copies of SharePoint as I want. It doesn't work that way. But for SQL Server, it actually does. So that means that if I buy a 2-socket license for this physical host and a 2-socket license for the other one, I've essentially got 2 fully licensed physical hosts that allow me to run as many copies of SQL Server on them as I want. So that means I can now start splitting off my content databases, start having a little more dynamicism in terms of how that works. I can fail over from one host to the other, and I'm still fully in license compliance. The flexibility of virtualization gives you is actually a fair bit, because that now means that I can allocate 8 gigs of RAM to this one content database, whereas before you may have a 16 gig machine where we're sharing it among 6 content databases. That one content database with its dedicated RAM allocation will probably perform better than in a shared environment, because that's going to give you a little bit more oomph. So there's a reason that you may want to kind of start thinking about that, and also with regards to the virtualization licensing there as well. With regards to that database role, no matter what you're doing with regards to virtualization, always give it as much RAM as you possibly can, because that's going to give you good performance within a particular caveat that I'll get to later on. Offload disk I/O, so use fixed size VHDs. Don't use physical LUNs. I actually think fixed size VHDs are the best way to go, because they allow you to be able to move things along very quickly. You may want to take advantage of things like guest clustering, which I'll explain a little bit later on. But guest clustering is actually creating a cluster service within the virtual machines, so that instead of the virtual machines moving between different hosts, which we call host clustering, SQL Server application within a virtual machine can move between it and another virtual machine. This is going to allow you to be able to upgrade SQL Server, patch it a lot more easily if you do that. Right? That's some functionality as well. I strongly encourage everybody to take their key content databases and also mirror them. So mirror, use SQL Server database, synchronous database mirroring, and that way you're going to ensure that you get the quickest overall failover from one SQL Server to another. Now this works in SharePoint 2010. It does not work in SharePoint 2007. Okay, so SharePoint 2010 has full support for database mirroring. And how many here have actually tried that? Anybody tried mirroring 2010? Okay, how many have heard of it? Okay, how many know where to configure it? Okay, a couple of you. Let me actually just show you very quickly where to configure it. Assuming my environment is still up. Okay. Okay, let's get the right RDP session up. Here we go. Okay, let's hope this works. Okay, it kind of works. All right, so I have here a copy of SQL Server Management Studio that's running, and I have two SQL servers that are running. SQL 02, which is running a content database, and its database mirroring principle synchronized. And as I scroll down, on SQL 01, there's the actual mirror copy of it as well. And what I've essentially told SharePoint is, in central administration, when I go to manage content databases, everybody remember this? Okay. I picked the right web application, which is the intranet one. I click on that content database, and there is a couple of different options that I set. First of all, what's the database server? So in my case, the primary database server is SQL 02. And as I scroll down, I also have the option to specify in SharePoint 2010 what a failover database server is. In this case, SQL 01. Right, so now I've got the capability to tell SharePoint that for this particular application, this content database, if you can't connect to SQL 02, try connecting to SQL 01. And this allows me to make sure that that content database is always available. In synchronous database mirroring, we're copying every single transaction to both SQL Server instances simultaneously, and the commit is not complete until it's successful on both. That's what synchronous database mirroring means. What it means in practice with regards to what users actually see is, should that first SQL Server fail for any reason, the second one is going to take on the workload. And the first user that connects to SharePoint and tries to do something after that failover occurs will, by default, unless your application traps for it, get an error. If they do a refresh, they'll be fine. Not just the way that SharePoint happens to implement database mirroring. It's not the cleanest approach, but it's the one that happens to work. So that's configuring database mirroring on a SharePoint side. By the way, database mirroring is fully supported in all versions of SQL Server from 2005 on. It's actually something that's available even in Standard Edition. So Standard and Enterprise have both database mirroring available to you. So now we get into, okay, understanding which roles and the impact this may actually have. How do I then make sure that I'm getting the best overall performance for the different key resources that we're going to use, which is CPU, memory, disk, and network, when I virtualize my SharePoint infrastructure. So what are some of the considerations there? So when you look at CPU, two things to keep in mind. Okay? So in a physical environment, essentially performance is governed by how fast your CPU is, how much power it draws, all that kind of stuff. You want a faster versus a more efficient processor that kind of gives you a bit more consumption costs. Try not to do things like throttling or thermal thresholds. Make sure that you don't configure some of those things. You want to have typically a hard number of processors with multiple cores in a lot of cases, although that may actually work against you depending upon your RAM configuration. And make sure that you have kind of the best overall hardware architecture to support best overall performance for your virtualization host. On the virtual side for SharePoint, you want to configure a one-to-one mapping of virtual CPU to physical CPU for best overall performance. In other words, if you have 2 quad-core CPUs on your host, right, you want to allocate a maximum number of CPUs that you can within a virtual machine of 4 to that particular virtual machine, which will then map back onto a single socket with 4 cores. You want to kind of do that one-to-one. What you don't want to do is you have a 2-core host and allocate 4 CPUs to a virtual machine. Because at that point in time, you're time slicing. So don't exceed the physical number of cores within a physical host in the calculation of all your virtual machines. If you can avoid it. In some cases, that'll work just fine, but if you can avoid it, try not to do that. Okay? Again, be aware of virtual processor limits for different guest operating systems, so make sure that the CPU that you're using applies to the OS. For Windows Server, it's a maximum of 4. And again, there's typically some CPU-bound issues where you actually have the CPU doing a lot of the work. So network cards within a virtual machine can be synthetic or emulated. Okay? If they're synthetic, they actually get hardware assistance. If they're emulated, it's a CPU that does all the work. It's the virtual CPU. That requires a lot more work, so therefore try and avoid that. Try and use synthetic as opposed to emulated, if you can. Memory, I love this first one. Make sure you got enough RAM for all your virtual machines. Kind of a given, right? Try and have as much RAM as you need for your virtual machines. If you need more RAM, get more RAM. There is a little bit of overhead for the hypervisor. In the Windows world, it's about 512 megabytes overhead for the hypervisor itself to do its thing, which is the OS level. And again, always use SLAT-based hardware for the lowest memory management overhead because you're offloading the memory management from the operating system back into the hardware that you're running the host on. Now, you guys probably think that the first statement of the virtual is kind of a given. Configure the right amount of memory. Well, what's the right amount of memory? Well, look at the specs and find out exactly what's being asked for to make sure. NUMA is going to either help you or it's going to kill you. Non-uniform memory access. How many here have heard of NUMA? How many know what it is and what it actually has as an impact? Okay, a few of you. Good. Because the ones that don't, you're going to be a little surprised with the next slide. Always allocate sufficient RAM so that you're not going to have paging and swapping issues. So the same problem you're going to have on a physical host running SharePoint or any particular application, you're going to have in a virtual one if you don't give it enough memory. So, running out of RAM is going to cause paging or swapping, and paging is going to increase CPU load as well as I/O, and that's going to have a negative impact on performance across the board. So make sure you allocate sufficient RAM to begin with. If you are using VMware, try not to overcommit. If you have to, you have to. But what ends up happening, you do overcommit, you could potentially end up going to disk. That's a little slower than RAM. And for Hyper-V, again, determine whether or not you want to use dynamic memory. But if you are going to use dynamic memory, do not over-allocate the memory in the virtual machines. Make sure it's not more than 10 or 15% of the physical RAM in the machine. So let's talk about NUMA. Yeah. At the physical hardware level, there is a boundary for memory access, because this is kind of going back into mapping memory with regards to CPUs and getting the right allocation of both, and then understanding what those boundaries are. Essentially what NUMA means is the amount of physical RAM in your host is going to end up being kind of divided by the number of cores you have on your CPUs all up. So I'll give you an example. Okay. If you have a 64 gigabyte memory configuration for your physical host, and you have 2 quad-core processors in that particular physical host, you've now got 8 cores and 64 gigs of RAM. So the ideal configuration for your virtual machines is 64 divided by 8, which is 8 gigs of RAM. That's going to allow the memory management at the hardware level to actually have the best overall performance to ensure that your virtual machines get the best bang for the buck. Crossing a NUMA boundary is very, very expensive. In that if you allocate a single virtual machine 12 gigabytes of RAM in that configuration, you're going to cross a boundary because you're going to have one 8 gig NUMA allocation for that one physical core, and then a second 4 gig allocation that's going to now be part of something else. That breaking of the NUMA boundary is about a 30% performance hit. So you need to look at how many cores or how many CPUs am I allocating to the virtual machine. Okay? What's the NUMA configuration of the physical host that I have, and then how much RAM should I allocate? In SharePoint, what that essentially means is, especially if you're doing things like web front-end roles, you're going to get significantly better performance by configuring 2 web front ends with smaller RAM allocations than you are with one web front end with a lot of memory allocation, because of that 30% hit with regards to NUMA. So, if you have 2 CPUs allocated to a virtual machine, you can allocate 16 gigs of RAM in that configuration, and so on down the line. But be aware of the fact that the NUMA boundary is actually going to cause you a performance hit. And it's not going to be a small hit, it'll actually be a big hit. It doesn't matter whether you're running Hyper-V or VMware ESX, it's the exact same issue, because it's done at the hardware level. Okay? I had a customer the last time I delivered this session, basically, tell me before the session started that, yeah, we're not really happy with running our SharePoint infrastructure in a virtual environment because we're finding that the performance is nowhere near as good as running it physically. I said, okay, well, we could talk a little more about what that is after the fact. And then I started talking about NUMA, and he goes, I think you may have solved my problem. Because they were allocating, they have a machine that had 128 gigs of RAM. They were allocating 2 CPUs, okay, and 32 gigs of RAM to a virtual machine, but they essentially had only 4 cores in that box. So they were really crossing the NUMA boundary. So it's one of the things that you need to watch out for. So, having the right allocation of memory with regards to the NUMA boundary is very, very important. So think about that when you're looking at the hardware that you have and what you're going to allocate in terms of RAM to the virtual machine based upon the number of cores. Yeah? Oh, the mic, good.
Would the configuration of crossing this NUMA boundary, would it mean that, for example, if I configure it to 9 gigs, would it mean that the performance would be slower than configure it as 8 gigs?
Absolutely. So if you look at this situation here, you've got 8 cores and 64 gigs of RAM. So 64 divided by 8 equals 8. So if you allocate up to 8 gigabytes of memory and 1 CPU to the virtual machine, you're going to get good performance. If you allocate 1 CPU and 9 gigs of RAM, we now have to switch between NUMA boundaries. And that switching, even if it's done at the hardware level, is a very, very expensive thing to do. And that's going to cause you a performance decrease. Now, if you allocated 2 CPUs to that virtual machine, you could potentially allocate up to 16 gigs of RAM to it and you'd still be okay, because it's on a per CPU basis. But it goes back to my previous statement about do a one-to-one mapping of CPU to physical to virtual CPU. Because if you exceed that, then all of a sudden the rules change too. It gets a little more complicated. So it's very, very important to kind of keep that in mind as well. By the way, the new CPUs that are coming out right now do multi-core hyper-threading. So your 8-core machine looks like a 16-core machine. Yeah. Mixed reviews on this one. My recommendation is don't hyper-thread unless you've got huge amounts of RAM. Because again, at that point in time, you're kind of giving the CPU 2 things to do at the same time. It could potentially do it, but it could also potentially be a bit of a performance drain down the road. This is the one really, really important thing I want you to get out of this particular session is be aware of NUMA boundaries, because they can actually cause you a lot of grief. Again, look at the number of physical CPUs, virtual CPUs you're allocated into the machine, and then the amount of RAM in the machine total. But you got to divide the physical RAM by the number of cores that are physically there, and then also look at how you're configuring your virtual machines as well. Really important thing. Question over here?
Would you take the hyper-threading into account into the NUMA boundaries?
Great question, yes, because it actually does factor into NUMA boundaries as well, because it's considered a core, right? So if you ever go to a host that has multiple cores and hyper-threading as well, if you go to the properties that it'll actually tell you that it's got, like, instead of 8 CPUs, it's actually got 16. So it's counted as a physical CPU. So that actually has an impact too.
So you give a rule of thumb for detecting NUMA boundaries, okay, but you have a disclaimer that it varies. I mean, is there a way to basically figure out what the NUMA boundaries actually are on the specific hardware?
Great question. You know how you do that? You go back to the technical specifications of the motherboard you're using. It depends on the vendor of the motherboard and how they implement it. But general rule of thumb is most of them implemented this way. But yeah, there are slight variations, but typically means take the amount of physical RAM divided by the number of cores, and that'll kind of give you the boundary. I've used that across the board, and it seems to work well, but there are slight variations that will impact you, but I haven't seen a huge impact in the variations. Actually, can you go to the mic, because I honestly cannot hear you up here. Sorry.
So with the NUMA boundaries, if you actually allocate less per core, does that affect you negatively as well?
No, if you allocate less, you're okay. So
Okay.
you create 2 virtual machines with one CPU, and you're still okay with 4 gigs of RAM on each one, kind of thing. Yeah, that's okay.
Okay.
As long as you don't cross that boundary and go over the amount. So I told you it was going to be a good point of discussion. So again, keeping the boundaries in mind, this means you would get significantly better performance provisioning 2 SharePoint front end with half the amount of RAM as a single front end with twice as much RAM, keeping in mind the number of CPUs that you have. And again, it applies to any virtualization platform, not just Hyper-V. It's a hardware-based limitation. It's got nothing to do with the virtualization vendor. Disk, make it fast. It's probably a good rule of thumb, right? So make sure you're using the fastest SAN infrastructure. You'll note that I don't really talk a lot about direct attached storage anymore. Really are starting to go to SAN type stuff. I think SANs are definitely the way you want to go with virtualization, because without a SAN you can't do clustering. Without clustering you can't get the availability you need. So you really want to start having a SAN infrastructure. And it could be something, if you're a small organization, it could be something as simple as throwing up a copy of Windows Server and then installing the Microsoft iSCSI target. And at that point in time, you've got an iSCSI SAN with a bunch of disks attached to it. It's pretty easy to go ahead and do. In fact, one of the blogs that I published, we have a series of articles about how to go ahead and configure the Microsoft iSCSI target to create your own SAN. It's a very, very low-cost thing to go ahead and do. But you want to make sure you get the best overall, fastest performance on your SAN infrastructure, and then put all the VHD files for your virtual machines on the SAN. You can do direct connection to an iSCSI SAN, like I mentioned before. A lot of folks using fiber channels still these days. Make sure that whatever SAN you're using, you take advantage of it appropriately. Again, make sure you get the fastest overall disk infrastructure, especially for things like SQL Server in particular. So web front ends is not that much of an issue. Index server is a big issue. SQL Server a big issue as well. Those are the ones you want to make sure you get the fastest overall disk cable for them to go ahead and do what they need to do. So really fast is important for those disk-intensive applications like index servers and like your database server. Also, don't put everything on one basket. Now, with the SAN backend, a lot of this stuff is abstracted to you. So as you're creating your LUNs, make sure that the LUNs that you're using for your SQL Server database are different than the LUNs you're using for some of your index databases and so on down the line. So try not to put everything in one particular set of LUNs and put them all on different elements. With regards to the virtual machines, if you are going to have multiple disks, on Hyper-V, for example, your boot disk for your virtual machine must be IDE. We don't support booting off SCSI within Hyper-V. VMware, on the other hand, boots off SCSI by default. However, if you want to add additional, hard drives onto your virtual machine, you want to specify SCSI, because that allows you to have we call the capability to attach another VHD file to your running virtual machine without any downtime. So it's kind of a live edition of storage. Question over here?
So I was wondering which roles do you really need the RAID 10 for, and which ones can survive with like a RAID 5?
RAID 10 is always best because it's the fastest, right? So anything that's going to have more write-intensive operations, you want to go ahead and have RAID 10. Anything that's going to have more read-intensive operations, you want to have RAID 5. But ideally, you want to try and use RAID 10 as much as you can.
Even on the front-end web servers?
Front-end web servers don't actually need... Front-end web servers, you can use local VHD files that are basically on a RAID 5 backend. Front-end web servers don't actually have a lot of disk requirements, right? They're mostly memory and CPU intensive.
Okay.
I noticed in a number of these sessions talking about RAID 10, RAID 5, what to do, and you know, in a virtualized SAN, you're going to use VRAID, and typically in like what HP generally recommends. And I just wonder, you know, if you address that. And I just keep hearing the same message, and there's so many people I know that are using virtualized SANs that, you know, the vendors will recommend to get the best number of IOPS, you know, that you're spreading that over all 90 or whatever disks you've got in there.
Yeah, see, I'm not a believer that you actually have to spread everything across all the hard drives. I actually like the capability to be able to allocate different disks to different LUNs and have a better sense of exactly what's happening in the back end. A lot of that is also, you know, following vendor practice is a good idea because they obviously know what they're talking about and they're going to give you the right guidance. From my perspective, you know, the one thing I do want to say is don't put everything on just one set of LUNs that are all using the exact same physical disk, because once you start having those disks start to die, and they will, disk will die. It's a known fact. If you get too many of them dying, it could actually have a negative impact that's broader than if you start to have multiple LUNs configured using multiple physical disks independently of each other. So there is no clear-cut answer on that one. I just don't like having everything spread out across all 90 disks and then having to worry about the fact that 5 of those disks are going to go away at some point.
Just to respond to that, like working with HP, I think they say their statistics show that, like with VRAID, you set up how many disks of redundancy you've got, and they typically recommend only one disk if it's if you're using, you know, fiber channel disks. If you're using something around 90 or less, and if it's more than that, then looking at 2 or so based on their statistics of collected data. But
you know what, though? I've been in this industry way too long, and maybe I'm just cynical, but I like to be a little more safe. So I mean, I'm not going to go against what they're saying. You know, they understand what they're doing. I'm a little bit more, shall we say, paranoid. Been there, done that, been burned a few times. Okay, so back to the virtual configuration. Again, if you're going to have local storage within a virtual machine, use SCSI instead of IDE, but the boot drive will have to be IDE. Don't use dynamically expanding disks. Use fixed-size VFDs like I mentioned before. If you are going to do a direct SAN connection, which for things like SQL Server and guest clustering is required, iSCSI is the only option you can actually do. Make sure that you understand the read-write patterns of what's happening with regards to your virtual machine as well, so that you get the proper issue with contention taken care of. And also work with the vendor to make sure that they understand that you're using virtual disk storage or virtual machine storage, and that their SAN is actually optimized for that as opposed to any other kind of workload, because there are some differences in terms of how that works. In terms of network, use gigabit or 10 gigabit adapters as much as possible. The virtual disk adapters within Hyper-V, for example, are on all 10 gigs by default, no matter what the underlying physical architecture is. So, you know, the virtual machines will all report that they have 10 gig adapters, but the reality is it's going to be limited to whatever you have physically within the configuration. Have multiple NICs in your hosts, and have multiple NICs dealing with different types of workloads. So let me give you an example. If you're going to have iSCSI storage, okay, have dedicated NICs both at the physical level as well as at the virtual machine level that are going to deal with iSCSI traffic. If you're going to have clustering configured, have different NICs that are going to deal with the clustering traffic. Have different NICs that are going to then be dealing with user traffic. Segregate that as much as possible because you can create multiple NICs. You can also create multiple VLANs in your switch configuration. So make sure that you actually do have that kind of properly delineated so that you're not going to have one set of physical NICs having traffic from all types of different types of elements, iSCSI, as well as your host-based stuff and clustering. So you still need to follow those exact same best practice rules in terms of how to go ahead and configure clusters when you go virtual, because you want to make sure that you get the best overall performance. On Hyper-V, make sure you install the most recent version, or we call the integration components or enlightenments. That's going to give you, at the virtual machine level, the most up-to-date set of drivers that are going to have the best interface with the network cards on that particular machine. So this is going to give you the best overall performance. The same for disk I/O, the same for everything else. For Hyper-V, there's actually two types of network adapters you can configure. One's called network adapter. The other one's called legacy network adapter. Never use legacy. Always use network adapter. Legacy is kind of compatibility with Virtual Server 2005 R2. You want to just head to the mic, it's going to be a lot easier because I honestly cannot hear anybody further back than 2 rows.
For the hardware, from the hardware vendor standpoint, if you have network teaming available with HP, with IBM,
Yep.
or if you buy an Intel NIC, is that supported, and how does that work?
It's actually supported fully within the Hyper-V environment as well. So from the virtual machine perspective, if you have team adapters, we're just going to see one particular adapter at the guest level, but then how that's physically implemented is going to be dependent upon the way the hardware itself is configured. Go ahead.
Will it see aggregated bandwidth if your switches support teaming in that respect, like your Cisco switches?
So I think at the Windows level, at the hardware level, you're going to see that. In the virtual machine, you're going to see a 10 gig adapter.
Okay.
Right? Hey, Rick. One of my Canadian buddies with the hat in the front row. Also a great guy for virtualization, just so you guys know. All right, so let's get to high availability. This is probably the most fun part. Virtualization gives you an easy way to configure a high availability. In terms of how you do that, hello, click. There we go. You implement clustering. You implement clustering at the hardware level between different physical hosts. When you do that, you've actually got the capability to have a much better way of ensuring that if you do have hardware failure, it's not going to impact the workloads themselves. Right now, if you do virtualization, you're going to have potentially 20, 30, 40 virtual machines on your host. That host goes down, that's 20, 30, 40 different workloads that no longer work. Okay, you think your phone rang a lot before, wait till this happens. So you want to make sure that you have some way of protecting yourself against that taking place. And the way you do that very simply in the Hyper-V world is being able to create a cluster. And it's a pretty easy thing to do. There's a number of different options in this. I'm sure there's other sessions here at TechEd that talk about it, and I've seen a number of them. What you essentially want to do is make sure that you configure clustering. So let me go back here to my demo for a sec, and I just want to show you my configuration of the cluster. There we go. Hey, there we go. Everybody see that okay? I think it's kind of there. So what I've got here is I have a cluster called hvc1.tech.lab, which has 5 services, which are all virtual machines, my SharePoint, my 3 SQL servers, a SQL client, running on what we call 2 nodes. So these are the physical machines, node 1 and node 2. And we also have something called clustered shared volumes, which is essentially storage that is being shared among those hosts. So both hosts can see the storage at the exact same time. So if I were to, for example, blow up one of these hosts, what will end up happening is all the workload that is on that host that died will now end up being transferred over to the other host. And that will take place in about a minute. So typically less, but it can be as quickly as a minute. So if you look at what I've got on node 2 here, so node 2, as you guys see here, has my SharePoint 01 virtual machine, and has also got my SQL 02 virtual machine. So if I were to blow up node 2, what will end up happening is we're going to very, very quickly be able to restart my SharePoint virtual machine as well as my SQL virtual machine on the other node, as opposed to having to rebuild it in case something goes wrong. So it's very, very important that as you're going to start considering virtualization, you always take into account high availability. You need to go ahead and do that. With Hyper-V, this is out of the box, right? So as long as you've got a SAN backend, shared storage infrastructure, Windows, out of the box, supports clustering. Failover clustering is something you get. Failover clustering of virtual machines is relatively easy to configure. You basically go to the virtual machine and say, I want to make it highly available. Once you do that, it's properly configured on that particular SAN. So if I were to do something really, really bad, look, let's say I'm going to blow up my node 2. Rick, should I blow it up? Rick said he can do it. All right, so I'm logging in. Anybody here use Dell equipment, just out of curiosity? If you do, you're probably familiar with the iDRAC software. So I'm actually connecting to the PowerEdge R610, which is my Node 1 machine. It's a little bit old. And what I'm essentially going to do is once this loads up, you'll see that it's currently running. I'm just going to scroll down here so that everybody sees that I am, in fact, connecting to Node 2. You see that? Which had my SharePoint virtual machine and my SQL Server one. And, I'm going to simulate killing it by doing a power cycle. Anybody scared yet? No? So let's kill it. And that's going to, at this point in time, reboot that particular host. And in doing so, it's probably not going to do a nice thing for my SharePoint infrastructure. So once I refresh that, okay, you'll note very quickly it recognized the fact that there was something wrong, and it's bringing up SharePoint 01 and SQL 02 on Node 1. They're actually pending to go to that particular node. Very quick detection, being able to go ahead and do that. This is going to incur downtime. Right? It's going to be very, very quick downtime. It'll be less than a minute typically, but you're going to have downtime anytime you have clustering when a particular physical host fails. However, significantly less downtime than if you had a physical host running SharePoint die. Because all this means we have to just simply switch it onto a different host. And you'll see that it's currently online already, so that was done. How long did that take? About 30 seconds? So it's up and running. Now, the downside of actually having this happen on my SharePoint infrastructure is now we need to kind of repopulate all the caches on the web front end and that kind of stuff because essentially it has died, and my SQL Server as well, because it's on the same host, has also ended up dying. By the way, bad move that I just did here. Don't put your database and your SharePoint on the same physical host. You probably want to offload them, right? So this is actually on purpose. I did that on purpose just so you guys could see. This is a bad idea. And if I were to go to my other virtual machine, which is over here, and go to my SQL client, here is my intranet site, which is running the SharePoint. Now, hopefully it's come back already. When I connect to it, it'll probably take a little bit of time. Well, it will eventually come back and very quickly be able to go ahead and allow me to access that. And there it is. It's already came back. So it's connecting to it, and it's just going to go ahead and do its thing. But the real advantage of doing things like failover clustering is when things blow up, they fix themselves relatively quickly. You don't necessarily have to worry about the fact, is it going to come back up? Now, in planning this, make sure that you properly go through and allocate a right amount of resources on each of your physical hosts to allow those virtual machines to come back up as required. And if you are using things like dynamic memory, that you also take that into consideration because you may in fact end up potentially for a short time having that host have a little bit of more of a workload than it should. You can also do things like automatic via mobility. I can do a live migration, which with the 5 minutes left I'm actually not going to show you, but I can. Hello. Okay. Now clustering, what you saw there was an example of what we called host clustering. Okay? Host clustering is the diagram on the right, where a virtual machine would move from one host to another. Something goes wrong, that virtual machine becomes a cluster resource, moves from one host to another. That also gives you the live migration piece, so I can live migrate it from node 1 to node 2. I can actually do that essentially any point in time I want to, but I'll show you that later on if I have time. Guest clustering is the applications within a virtual machine are then clustered. So a typical example that I use for this is SQL Server. I will cluster SQL Server within a virtual machine and have the storage point to a nice SCSI SAN because it needs to be able to go ahead and do that. And should anything happen to the application, should SQL Server hang on one of those particular virtual machines, one of those guests, it will then get restarted automatically on the other one. So this prevents you from having application failure. So host clustering prevents or deals with the issue of host failure. Guest clustering deals with the issue of application failure within a virtual machine or individual VM failure. Both are supported within a Hyper-V environment. And what this essentially allows you to do is to have your SQL Server go from one virtual machine to another, preferably not on the same physical host. With guest clustering, one of the other things you want to go ahead and keep in mind is that you can specify through a registry entry the capability to prevent the virtual machines that are part of a guest cluster from physically running on the same physical host. Because once you do that, you've got a cluster that's now dependent upon a host that if it fails, the whole cluster dies. So there's a way to actually prevent that from happening as well in guest clustering. The benefit of that really is being able to more easily patch applications. So install and update a SQL Server or SharePoint. You do it on one particular virtual machine, and then roll it out to the other one, and you fail it over while that ends up taking place. In terms of SQL Server, I always focus on SQL Server from the SharePoint perspective, because if your SQL Server dies, your SharePoint farm's kind of more or less done, because that's where your data happens to be stored. So do in fact configure things like database mirroring. How many here are using FileStream with SharePoint 2010? Anybody? How many here know what FileStream is? Which is FileStream? Remote blob storage. Who's using remote blob storage? Anybody using RBS? 1, 2? Okay. Essentially what FileStream allows you to do is to not have the blob stored within a SQL Server database, but have it stored within a file stream, which is a directory on an NTFS partition. And in doing so, you actually get better performance than you would storing it natively within a SQL Server database. Database mirroring, if you are implementing remote blob storage, actually won't work. Not supported if you're using FileStream or remote blob storage. Again, do either guest or host clustering with regards to your virtualized SQL Server machines. So the disaster recovery, really easy to set up a virtual DR farm. Just take a copy of your virtual machines and move it over there. You now have an exact copy of your virtual DR farm if you need to. Very easy to go ahead and do that because of the fact that they're all virtual machines. It's not physical hardware you need to go ahead and do. From a data perspective, you can use log shipping to transfer your data across to get the most recent one, or even SQL mirroring, and what's known as asynchronous SQL database mirroring, where stuff gets copied across over time. And again, management tools to set up a DR site are something as simple as Virtual Machine Manager 2008 R2 lets you go ahead and do that. You want to make sure that you do have the disaster recovery element in place as well. In terms of other things, use SQL aliasing for greater flexibility. That way, if you do change the physical location or the virtual machine your SQL Server is running on, you can just update the alias. Use index, your dedicated crawl server. And again, the reason for doing that is when you don't have to propagate the query, it actually gives you better performance, fewer disk requirements as well. Make sure you got the best overall fastest network possible. SharePoint loves network. With everything it does, you need to make sure you get a really, really good network performance. And don't forget about database maintenance, backups, and so on. Those you want to make sure you take care of as well. Some key takeaways with my 1 minute and 12 seconds left. CPU, like I mentioned before, configure a one-on-one mapping. Memory, watch out for NUMA boundaries and configure sufficient memory for each of your virtual machines. Some of that may require a little bit of tweaking. Okay? Don't put, from this perspective, make sure that you're aware of how your virtual hard drives map onto physical layers so that you don't get into any disk write contention. So don't put the index server or database server on the same set of physical disks because they're going to get very, very write intensive. Again, use VLAN tagging for security and associate your SharePoint virtual machines to the same virtual switch, which just kind of makes sense. And also make sure you install integration components on all the VMs. Again, one of the things in terms of minimizing the amount of contention within a SharePoint virtual machine, don't try and have a virtual machine do 15 things. Specialize. Don't have a particular virtual machine do 4 or 5 roles. Try and get it down to 1 or 2. Typically 1 is going to give you the best overall performance. And load balance your virtual machines across multiple physical hosts. Spread them out so that you don't end up having a potential single point of failure being a physical host. It's going to give you a lot of grief. Really important stuff. Know your vendor's virtualization feature set, whether that's Hyper-V or whether that's VMware, don't know what it is. Don't forget the SharePoint rules. Governance and everything else still is important. Okay? Snapshots are not officially supported. That one little element is kind of that potential of being able to roll back, but snapshots have a little bit of an issue on most of the roles, except the web front ends. Probably the only one that you can do snapshots with, but actually they're not supported any role at all. Don't put too many virtual machines on a host server. Balance them out as much as you can. And again, if you do dynamic memory, do not allocate more dynamic memory on the virtual machines together than 15% over the amount of physical RAM you have on the machine. Your host is still going to be a single point of failure. Protect yourselves against it by clustering to make sure that you do, in fact, take into account, if a host does fail, how that's going to have an impact, and making sure that your virtual machines still stay up, even if the host does, in fact, fail. Again, don't fight SharePoint. Use the rules of SharePoint, how to deploy it, how to architect it. It still applies whether it's virtual or not. You can cut costs, get consolidated equipment, get a great advantage of hardware resources with virtualization. That's why you do it. And make sure you've got the proper processor, architecture, and operating systems for your virtualization. Plan for availability, and make sure that you do take into account the fact that some of these things may go down, and always measure performance. And if this sounds like a lot of work, 365 might be an option as well, where we do all the stuff on the back end for you. Right? So for those of you that actually haven't seen it yet, this is now in beta. Office 365 is actually based on SharePoint 2010. You can, in fact, do customizations for it. It's using a sandbox environment to do that. We have a 99.9% uptime guarantee, rich programming model. Web apps are part of it out of the box. And also you get a public-facing site for free as part of web apps. So you can actually configure that if you need to. I'm not going to go through these. The slides are available. All these are hyperlinks to different things you can go ahead and take a look at to help you with virtualization. Please do so. And all the other sessions that potentially you may want to take a look at as well. I like VIR 304, planning a highly available virtualization environment. Take a look at that one if you haven't already. I think it's really important to do that. And with that,